Oh, this is pretty much the last new thing we're going to learn together.
All year?
Yeah, all year. Yeah, this is it. This is the last topic of the entire year. Yeah. So, and this is actually something you guys could already kind of do but I wanted to teach you this just so that you can get some guidance on it. And it's to do tough, weird trig integrals. That is, we're going to start doing trig integrals, sines, cosines, tangents, secants, cosecants, cotangents, only they're going to be harder than any you've done before. And that's it. That's just harder versions. So let's start. And they come in many different categories. I mean, I'll tell you right now in my planning book, you're going to be learning power rule with sine and cosine, power rule where the power of sine and cosine are both odd, power rule where sine and cosine are both even, then power of secant is even, power of tangent is odd, power of tangent is even, just all these weird scenarios that you're going to learn some tricks and techniques for. And I just want to prepare you because sometimes the AP exam, it'll help you to have this knowledge. So here comes the first of about 10 examples of weird trig integrals. So here comes example number 1, the integral of sine to the 5th x cosine x dx. Okay? Hey, you tell me, what's my u going to be? And this is all u substitution, or most of it is u substitution. So what's my u going to be? Sine. Yeah, heck yeah. And why is sine of x a really good choice for you?
Because the derivative of sine x.
Yeah, because the derivative of the sine of x is cosine of x, right? So you get to go, hey, u equals sine of x, and so du equals cosine of x dx. Here's my du. And so I end up getting u to the 5th du, which is 1/6 u to the 6th, or 1/6 sine to the 6th power of x, plus c. You guys okay with that?
Yeah.
Those type of problems are incredibly easy. But what if I give you a problem like this? Example number 2, where you have the integral of sine to the 3rd power of x cosine to the 4th power of x dx. Now, it's not immediately obvious what my u is going to be. You tell me, what should my u be? Should my u be sine x or should my u be cosine x?
Cosine x. Cosine 4.
Okay, hey, let's have a vote, because it certainly isn't going to be cosine to the 4th power. Because if I choose my u to be cosine to the 4th power, then my du would be 4 times cosine to the 3rd power sine negative sine x, and I don't have a cosine to the 3rd power hanging out here. So no, your choice has to be either cosine x or sine x. How many people say with Andrew that it's cosine x?
Sure.
Okay, how many people say it should be sine x? Okay, great. Andrew, why are you a voice crying in the wilderness? Why are you the only person, except for Daniel, going with cosine x?
Because it has a larger exponent.
Okay, that's not the way you choose. I'll tell you why. You know what you choose? You choose cosine x because the sine has an odd exponent. Okay, so if the sine or cosine has odd exponent, choose the other one. That's the big rule on this guy. And so if I choose my u to be cosine of x, so that my du ends up being negative sine of x dx, and you can say, okay, well, I need to reserve a sine of x to be my du, correct? So this becomes sine squared x cosine to the 4th of x times sine of x dx, and now I'm happy. I've reserved, one of my sine x's to be the du. What am I going to do with that sine squared?
Turn it into u squared.
Turn into what?
Oh, wait, no.
No? Gosh, I wish these were all cosines, because if these were all cosines, then I could just replace every cosine with a u. But oh, this is a sine, sine. Yes, Chris?
U into 1 minus cosine squared x.
Thank you. That's your strategy.
Oh my, that
Okay.
is beautiful.
Yeah, so this ends up becoming 1 minus cosine squared of x, cosine to the fourth of x, times sine of x dx. You see what I mean? And now it's all good. I've turned all of this into u's. This is my du, except I'm going to have to sprout a negative sign there. And I can carry on with the antiderivative. Okay? Why could I not do it the other way? Why couldn't I let my u be sine x and my du be cosine x? Why wouldn't that work? Yes?
Because when you go to when you do the du, cosine is going to be the fourth. It's going to have the, and when you turn it into the du, it's going to be cosine to the third, and you can't do the trig identities with odd.
Thank you. I'm not going to be able to turn all of my cosines into sines if after I reserve a cosine x for my du, I'm left with cosine to the third of x. I can't turn all of my cosines into sines if I've got cosine to the third power. I can only do it if it's an even power, because the relationship is cosine squared equals 1 minus sine squared. You see? So thank you, Andrew. You got it perfect. Yeah, so that's why if it has the odd exponent, he's the guy that you're going to reserve as your du. So now you've got an even exponent, and you can turn the rest of them into the other guy. So hey, let's go ahead and complete this problem. First of all, I need to put a negative there, which means there's a negative there. And so this ends up being negative integral of, do you mind if I just go right to u to the, oops. 1 times cosine fourth is u to the fourth minus u to the sixth. And then that's du. You guys okay with that? I'm just going to distribute the cosine to the fourth x through the 1 minus cosine squared. Except I'm turning all my cosines into u's. And so this ends up being negative 1/5 u to the fifth minus 1/7 u to the seventh plus c. And then this becomes negative 1/5 cosine to the fifth of x plus 1/7 cosine to the seventh of x plus c. You guys want to try one on your own?
Sure.
Okay, hey, give this a try. Integral of sine squared of x cosine to the fifth power of x dx. Hey, good luck with that, kids. Good luck with that. See if you can choose the right guy for you. I'll give you like 60 seconds. Here's example number 3. Can I interrupt you just for a second? What did you guys choose as your u?
Sine x.
Sine x.
How many people chose sine x? Yay, yay for each and every one of you. Okay, keep going. And I just want you to see, I do take that step of showing, hey, I'm reserving one of the cosine x's to be my du, then I deal with the cosine to the fourth. This is still not trivial. Go ahead and finish this problem. I know nobody got done, but I just wanted to at least make sure you got started, you know? Boy, that boba's good. Okay, hey, I'm ready to move on. Any question or problem on this? On this process? And I know, you're gonna get practice doing it. And there's really, you just do it this way. There's nothing more for me to say. Hey, let me give you another example. Here. What if I had the integral of the cosine to the 5th power of x dx? Someone tell me, how would I do that? Now, is the antiderivative of that going to be like 1/6 cosine to the 6th power of x? Yeah, no way. Because if you say, okay, the antiderivative is 1/6 cosine to the 6th power of x, it becomes immediately clear if you take the derivative of that, you get nowhere near that. Right? The derivative of this is going to be 6 times the cosine to the 5th power of x times the negative sine of x, and there's no negative sine of x here. So that's not true. That was a big mistake people made on the test that I just gave you, is I gave you a velocity vector of sine of t squared, and the fact is, there's no antiderivative to the sine of t squared. There's no function in the universe whose derivative is the sine of t squared, which means sine of t squared has no antiderivative. So the only way you could do the problem, oh wait, Lauren's in the class. I better stop. Okay, well anyway, you can't take the antiderivative of sine of t squared. So you're gonna have to do some substitution here. Anyone figure it out? What am I gonna do here? Well, sure. What?
Wait, isn't this gonna teach her how to do it?
No. No. What we're doing here has no connection. I just wanted to show kids that quite often the only way you can get the antiderivative of a weird trig integral is to reserve something for your du. But the sine of t squared, you can't get the antiderivative of it. There's nothing to reserve, That's all. But, you'll see when you see the problem. Okay, hey guys, I'm just going to tell you, this is an odd power, correct?
Yeah.
So let's reserve a cosine for my du. So now that I've reserved a cosine of x for my du, what do you suppose I'm going to do with this cosine to the 4th power of x?
Oh, you're going to do the 1 minus sine squared.
Thank you very much. I need to turn these all into sines, because by making cosine x dx my du, I've committed myself. Just like if you make out with a girl, I'm sorry, you're committed to being their boyfriend now. You can't get around it. Once I've put my cosine x dx as my du, I'm committed to my u being sine x, right? My u has to be sine x. And if my u is going to be sine x, okay, then I better turn these guys into sine x. So you know, cosine to the fourth is cosine squared squared, so it'll be 1 minus sine squared of x squared times cosine of x dx, which is, you know, so u is this and du is this. So I end up with 1 minus u squared squared du, so I got 1 minus 2u squared plus u to the fourth du, and at this point I'm going to say etc. Okay? And so one thing I'm training you guys to do is how incredibly useful it is to figure out what your du is before you figure out what your u is. You're going to let the tail wag the dog, so to speak, you know?
Did you do negative sine of x, or is that just sine x?
That's sine x. I just bad, fast, bad writing. There you go. Wait. There you go. Yeah, that's better. Yeah, let u be sine x and my du is my cosine x, because that's all I had. That was my only choice for my cosine x. Okay? Now, here's the weird thing though. When my power of sine and cosine are odd, then it becomes very easy. I take peel off one of the sines or cosines and put it as my du. But what if the power of sine and cosine are both even? Here, let me give you this one. Example number 5. This is the integral, let me see, I think I'm going to do cosine squared x sine squared x dx. Go ahead and write that down. Now, I'm stuck in this weird situation where I can't peel off a cosine to be my du because I'm left with a single cosine that I can't convert into sines. And I can't peel off a sine of x to be my du because I'm left with a single sine of x that I can't convert to cosine. So in order to deal with both sine and cosine being even powers, I have to do something utterly different. And here it is. If power of sine and cosine are both even, do this. Okay? We have a double angle identity that says that the cosine of 2x is equal cosine squared x minus sine squared x. That's our double angle identity for cosine. How many people in this class remember that from last year? Okay, then you guys need to fill your brains with more important stuff. Because the fact that you actually remember this is bad. You know? I mean, it's like remembering how many home runs Willie Mays has, you know, 660. Why would I remember that when there's so many more important things to remember? I can't remember like my anniversary, but I know how many home runs Harmon Killebrew has, 573, you know. So sorry you fill up your brains with worthless stuff, but here it is. So that means I'm going to make a substitution. Cosine 2x, I can substitute 1 minus sine squared x for the cosine x, correct? And now I'm going to solve for the sine squared of x. So I have cosine 2x equals 1 minus 2 sine squared of x, or sine squared of x equals 1 minus cosine 2x over 2. That's one substitution you're going to make. Wherever you have even signs, for every sine squared, you're going to substitute 1 minus cosine 2x over 2. Similarly, I could have said cosine 2x equals cosine squared x minus 1 minus cosine squared x, right? Which means cosine 2x equals 2 cosine squared x minus 1, or add 1 to it, so I got 1 plus cosine 2x over 2 equals cosine squared x. So that's a plus, by the way. So those are my two substitutions. I'll either do sine squared equals 1 minus cosine 2x over 2, or I'll do cosine squared equals 1 plus cosine 2x over 2. Yes? Sure. So that's the substitution we're going to do. And that's what you do. If the power of sine and cosine are both even, you must do these substitutions. Substitute that for every cosine squared, every sine squared. Substitute this for every cosine squared. Let me show you how this works out. My cosine squared is 1 plus cosine 2x over 2. My sine squared is 1 minus cosine 2x over 2. You guys okay with that?
Yeah.
Which means, if you don't mind, I'm going to factor out the 1/4. So I end up with 1 minus cosine squared of 2x dx. And now here's the weird thing. Cosine squared 2x. I can't take the antiderivative of the cosine squared. I have a rule that says if the power of sine or cosine are even, do this. What substitution do you suppose I'm going to make for the cosine squared of 2x? Is it yes to what?
I would say just that one.
Yeah, just this one, right? For cosine squared. Except you'll notice this guy says if I have cosine squared of x, it's going to be 1 plus cosine 2x over 2. What do you suppose it's going to be for the cosine squared of 2x? What do you suppose that's going to be? Yeah, multiplied by 2. 1 plus cosine 4x over 2. You see? The double angle identity says whatever the heck this is, just double it. Well, that's what I'm doing here. This guy's 2x, I've got to double it and turn it into 4x. Yeah, and so that's the substitution I'm going to have to make there. So I get 1/4 times the integral of 1 minus that guy, 1 plus cosine of 4x over 2 dx. And so I get 1/4 times the integral of 1 minus 1/2 minus 1/2 cosine 4x. You guys okay with that? I just split up the fraction, but I had to distribute this minus sign. So I get 1/4 times the integral of 1/2 1/2 minus 1/2 cosine of 4x. And now it's time to take the antiderivative. I get 1/4 times the antiderivative of 1/2 is 1/2 x. The antiderivative of 1/4 cosine 4x, 1/2 cosine 4x is going to be 1/2 times 1/4 times the sine of 4x. Okay, and now I can distribute the 1/4 if I want my answer to look like the book's answer. And I end up with 1/8 x minus 8 times 4 is 132. 132 sine of 4x plus c. I'm not going to have you practice one of these. You're going to get at least one of these on tonight's homework, or maybe 2 of these. Also, unfortunately, the AP exam occasionally puts these on. They like these problems, so you may encounter one of these on your next AP exam, and it usually won't be that difficult. It might be like they might give you the integral of the sine squared of 2x, something like that, where you're going, okay, well, step 1. I'm going to have to turn this into 1 minus cosine of 4x over 2, dx, and then you just go on and let it rip, Then this ends up being 1/2 x minus 1/8 cosine, 1/8 sine of 4x plus c. So they might give you a problem that's that simple, just to see, hey, do you guys know the substitution, So, hey, any question or problem on what you do if the sine and cosine are both even? Okay, then let's turn our attention to secants. Here, what's that, example 5? So here comes example number 6. Okay, the integral of secant to the 4th power of 3x tangent to the third power of 3x dx. Please check that out. I'll bet that's Science Olympiad. I constantly get texted by Science Olympiad. Wait. Oh.
Edison's texting you?
Yeah, he's trying to decide his schedule, and he's thinking he's going to take AP Physics C next year.
Who's Edison?
Tennyson, my son.
Oh, I thought you said Edison.
No, yeah, although Edison would be an interesting name too, but he's Tennyson. Yeah, if he wants to take Physics C, I mean, I'm actually opposed to it,
Oh,
but you know, it's his life.
Wait, do you not like calculus based on base physics? Or
No.
Physics based calculus? No.
Calculus-based physics on the high school level, I'm against it, because I think he should take it in college. But you know, it's his life, and I'd rather have him do, if that's what you want to do, I'm 100% for it.
They offer Physics C at his school?
Yeah, at Claremont High. We could offer it here, except the physics teacher refuses to teach it.
Lahava's calling?
Just a second. If that's what you want. Whoops. Just a second. I'm so sorry, you guys, but it's like he has to sign up for classes today.
Oh, he's a junior, right?
Yeah.
And he's taking calculus, right? Is he taking
Yeah.
AB or BC? Mr. Shane?
Yeah.
Is Tennyson taking calculus AB or BC?
What's that?
Is he taking AB this year?
AB, yeah. Yeah, and again, he's a junior. What's his hurry, you know? I mean, any junior who takes BC, you just have to question him, what's your hurry, you know? What is your hurry, you know? Taking a BC as a junior. But of course, you don't have any options here at Etiwanda. There's no AB here. But if we offered AB, although we offer college prep calculus, but that's not really AB, even though it kind of is AB. But the point is, yeah, my son's taking AB, so he'll get an A, he'll get an easy A.
Oh,
You know.
BC?
Yeah, BC. I mean, yeah, on Physics C. Physics C, what they do is they take 1/4 of college physics and stretch it over an entire year. And because it's a public high school, so he has none of the lab equipment that a college would have. So they don't spend a lot of time doing labs. So it ends up just being a very meandering, slow class. Yeah. But if that's what my son wants to do, I'm 100% in favor of it, because that's him. That's what he wants to do. Okay, I'm sorry, I got distracted by stuff that I shouldn't do. Wouldn't it be fun if the WASP people came in right when I was texting my son? You know, hello, Mr. Shana, how's your teaching going? Well, just one second. I was doing bell-to-bell instruction, except I need to text my son. Okay, great. Here's the thing. You got two choices. You've got two choices for your U. You got two choices for your U, either tangent x or secant of x. That's it. That's all you've got. Okay? Yeah. It's one of those two guys. And I want to say again, you're really letting the tail wag the dog. Okay? Your choice of U is going to be primarily dictated by what your DU is. So if you're going to choose your U to be tangent of x, then you better have a DU of secant squared x dx. But if you're going to choose your U to be secant of x, you better have a DU of secant of x tangent of x, right? I mean, that's what you've got. Now, of course, these are 3x's, so you know that's a 3 and that's a 3. But I want you to just think generically, you know? So my question to you is this. Should I let my U be tangent, or should I let my U be secant? Please think about it for a second, for like 30 seconds, and then I'll get your vote. Okay, you guys ready to choose? And I want every single person to make a choice, so be ready to raise your hand. You ready? Okay, how many people want to make their U to be the tangent of 3x so that their DU is secant squared? How many people go with that? Okay, beautiful. You guys are correct.
Oh.
But let me just ask, just out of curiosity, how many people wanted their u to be secant of x so that the du is secant of x tangent of x? Anyone went with that? Okay, Lauren, you're correct. Okay, did anyone else really want to go secant of x? Okay, because here's the thing. If your power of secant is even, then go with u being tangent of x, so your du is secant squared, and then all the other even secants you can turn into tangents, because you tan in a second, or you, what is that? I tan in a second? Is that what it is? Okay, but if your power of tangent is odd, then you can reserve one of those tangents as part of your secant tangent. You'll be left now with an even power of tangent. You turn all those guys into secants, and now you let your u be secant of x. So I just want you to see, I gave you a problem where you could go either way, okay? So let me write that down. If power of secant is even, choose u equal tangent x, reserve a secant squared of x for the du, turn all other secants into tangents. If the power of tangent is odd, reserve a secant tangent for the du and turn all other tangents into secants. You see it? Since the majority of you wanted my u to be tangent, I'm going to go with that. U equals tangent 3x, du equals 3 secant squared 3x dx. So I'm going to reserve a secant squared for my du. So I've got secant squared of 3x, tangent to the third of 3x, secant squared of 3x dx. That's going to be my du. Now, I am going to have to sprout a 3 there, which means I sprout a 1/3 there. So this equals 1/3. What is secant squared? What is it? I tan in a second?
Yeah.
I tan in a second. So my secant squared is 1 plus tangent squared, right? So I got 1 plus tangent squared 3x times tangent to the third power of 3x times 3 secant squared 3x dx. Alrighty. And now, do you mind if I make the u substitution now? Because I hate dealing with all these tangents and secants. So I got 1 plus u squared times u to the third times du, which gets me u to the third plus u to the fifth du. And so I get 1/3 times 1/4 u to the fourth plus 1/6 u to the sixth plus c. And so I get 1/12 tangent of 3x to the fourth power plus 1/6 tangent to the sixth power of 3x plus c. That's my son.
Are you sure?
Well, it's either my son or I don't know what it is. You know, luckily telemarketers don't text me. So I know if I get a text, it's either something completely worthless like a Science Olympiad text, or
You don't get texts from telemarketers? I get texts from telemarketers. It sucks.
what do they want to sell you, Viagra or whatever?
No, it's usually like women's clothing.
Oh, that's fine. Okay, and let me just remind you, you know, you could have done it Lauren's way, right? I mean, you could have done it Lauren's way, where you reserve a secant tangent okay? Where you reserve your secant tangent as your du, you turn your tangent squareds into secants, and then you go that way. So believe it or not, there's two possible answers for this question, right? One answer with a bunch of tangents and the other answer with a bunch of secants. And so I, as a teacher, have to be prepared to give you, to accept either answer, you see? Which is why on the AP exam, when they give a problem like this, they won't give it where you can do it either way, because it'll be a multiple choice problem. They want only one possible answer. Okay, well, hey, I mean, I feel I've given you the tools, so good luck on that stuff, and let me say bye-bye.